All right, young scholars. So I graded your programming assignment that was due last night. Pretty good, considering it was probably a fairly difficult program to do. Everybody got at least a 2 out of 3 or higher, so that was pretty good. You'll see on Thursday when we do examples that this week's programming assignment is much, much easier, as we will just be using an array to display all the members of the course. So today we're going to go through, and you may or may not have seen this in Programming 1, single and multi-dimensional arrays. So today we'll go through 2 lecture decks that are already uploaded on Blackboard for you guys to look through as you need to remind yourself what we covered today. And then on Thursday, my hope is to get through 4 example programs we'll do together. And in case we run out of time, we'll do the example that's related to the homework first before the others to prevent any issues. And if we do not get through all 4, I'll do again what I did last week and record and post it for you. Okay, so who understands what arrays are? Who had done arrays within Programming 1? Nobody?
I definitely did. I might need a refresher on it, but I definitely remember it, yeah.
Okay.
I have as well.
Okay. So the 2 that were with us for mobile apps yesterday also already had this review to some degree yesterday. But when you create an array, your number here is your number of elements within that array. So on slide 5 in the single arrays PowerPoint deck, we're creating an array called MyList that's only going to allow you to input doubles. In this case, we're going to have 10 doubles. So that means there's 10 numbers that are double, defined as double, instead of just integer, because they're probably going to have decimal places. So all of these are called elements. However, when you create an array, there's what's called an index. So the index is always that minus 1, because your index is always going to start at 0. So in this case, there's 10 elements. The index goes from 0 through 9. Franny, what if there were 8 elements here? What would the index be?
0 through 7?
Yes. So if there were 8 elements here, we would just go through 0 through 7. The index always starts at 0. So you know your last indexed item is going to be whatever your number of elements is minus 1. So in the example I asked Franny, if we change this 10 to 8, the index will run 0 through 7. So you could display one of your elements at a time by understanding where it is, where is it stored, where is it indexed, and then reference to it. So if we wanted to display the 5.6, we would have to display MyList 0, because that is that index. So when you're creating an array data type, you're going to start with the data type, in this instance double, and then the box brackets, and then your name. As I do, this name is kind of specific, my list. You're free to name them as you choose. It could be double bracket bracket, just LI for list. That's perfectly fine. It's entirely up to you. As I mentioned earlier, when you want to reference specific elements within an array, you need to know what index they're in. So in this example, we're creating an array called myList again that allows 10 elements defined as doubles to be inputted. So your first index is 0, your last index is 9. So what would the middle index be?
4.
4. It's 4 away from 0. It's 5 away from 9. It's much easier when you have odd numbers. So if we just had 9 here, and our last element was 8, what would be the middle there?
5.
5. Yep. So here we're defining how many elements will be in an array. Again, it's 10. So what would the index be? Lana, what would the index be here in this example? Double myList equals new double 10.
When you say index, you mean how many elements are in there?
No, we know there's 10 elements because that's what's there. What would the index be?
A double?
What would the index be? Double is what we're defining it as. Think back to the previous slide here.
0.
We would start our index at 0 and go up to 9. If this was 14, our index would be 0 through 13. So again, the index is always going to be one less than your number of elements because it starts at 0. So if you had 12, it would be 0 through 11. If you had 13, it would be 0 through 12, etc. You can also use the length object or class to return the value. Say you don't know how many elements you have in an array. You can use that function, object rather, to display back for you. So all of these can be done 3 different ways. You can create an array randomly using a for loop. You can have a user input the data, or you could set it up yourself. So when you're creating an array, you could do it 3 ways. You could have your typical numeric primitive data types like integer, double. You could also input character types as well as Boolean types. By default, you have 0 as your number. That's why you might use a for loop to create random numbers. By default, it's /u0000 for character types, and by default, it is false for Boolean types. With a Boolean, it's either false or true. So as I mentioned earlier, the index is 0-based. So if you have 10 elements, the index runs from 0 to 9. Calvin, what if you had 14 elements? What would the index be? Calvin's not with us. Franny, what would it be? 14
You said
elements.
14 elements, 0 through 13.
Yep. And if you don't know, let's say that the user's inputting the number of elements. So you're not going to know. The user on the other side might say, put in 5 elements. You can use that array ref var to determine how many elements you have. The reason the index are important is you can use them. What do you think this function is doing here? MyList2 equals MyList0 plus MyList1.
It's taking the third element and saying that it equals the first one and the second one.
Yep. Even if you have an element in the third indice, you could change it. In this case, we're changing it. Whatever element is in the first indice, the 0, plus whatever's in the second indice, the 1. So let's say we have the number 5 in the 0 indice and the number 7 in the 1 indice. What would our element be in the third indice? If we had 5 here and 7 here, what does this now become?
12.
Yep.
Well,
So let's say this element was initially 14. Now we've changed it to be 12. So think of the indice or the index as a storage place. You have a calendar, you write, appointments on it, other information that you can refer back to. That's exactly what's being done within an array. So in this example, you, as the person who's doing the programming, is putting the array numbers in rather than the amount of elements. So we have 1.9, 2.9, 3.4, and 3.5. How many elements is that?
4.
4 elements, yep. So the index would be 3. So 1.9 would be in 0, 2.9 would be in 1, 3.4 would be in 2, and 3.45 would be in 3. So this is in essence what you're going to be doing for the homework this week. You would have to declare string, let's say my class or this class as the name of your array, and then you would put everybody's names within there. Now you guys can still see the intro poster now. If you can see the intro post, you should be able to see everybody's names. Otherwise, let me know if that's not the case, and I will send all of you. Actually, when you get the email I sent out about the Zoom, everybody's name is on there too. So in this instance, as I mentioned, you're setting up an array called MyList with 4 elements labeled as double. So which seems easier to you? 1 line of code doing it all at once, or 5 lines of code setting up those elements? Lana, what's easier to you?
1 line.
1 line of code. I tend to agree. So what are we doing with this sample code here on slide 16? Public class test with our method. We're setting an array of how many elements here?
5.
5 elements, 0 through 4 is the index. So you notice on the side here, once the array is created, there's nothing in it. Everything is defined as a 0. So we're using this for loop to create our values. So our integer I initially starts as 1, and as long as it's less than 5, it increments by 1. So we're setting our value, our first index or element is equal to 1 plus 4. So it's going to override whatever is in the 0 index initially to be 1 plus 4. Does that make sense? That we can go ahead and overwrite what is in an index and change it?
Yeah, I'm following.
What instance would you think you would want to do that? Change a value of something.
If you made an error,
If you made an error, okay. But let's say you're using a calculator, or maybe even something you might do personally. When you go pay a bill, what happens to your bank account?
Your balance changes.
The balance changes. So that could be another situation where you want to change information, numbers, double, etc. So you might have to constantly be changing your balance. Same thing with an array. If you're not inputting values or creating the values themselves, you can constantly change them using a for loop, a while loop, etc. So initially we're setting our one element to 1. Then it changes with the increment. I becomes 2. 2 is less than 5, so it continues. So now our second indice becomes 3 because it's our previous indice plus the previous indice minus 1. So in this case, 2 plus 1. So the I is now 2 plus 2 minus 1. And it goes through and changes all of our elements as the code continues to run, so that we now have 1 in our indice 1, 3 in our indice 2, 6 in our indice 3, and 10 in our indice 4. So now what's going to happen to the indice 0? It's going to
now it's going to add what's up in index 1 and index 1 and index 4.
Yep.
So you'll get
11.
11.
Yep. As exactly as explained, you see on slide 11 here. We now have 10 in index 4. We have 1 in index 1. They were added together to give us the new number within indice 0. So you'll notice how it changed from 0 to 1. So the next few slides are different ways you would be able to use arrays. I'm just going to focus on slide 33 here. This is how you would create an array using input from a user. So in this instance, what's happening here? Can anyone guess from this code?
It's asking the user to input the array values.
Yep. So let's say you answer, okay, I'm going to put 7 elements in. So you'll be asked, enter values. You respond 7. The for loop then creates 7 random elements inside an index what? 0 through 6. But if the user inputs 14, what would the index be? It's always
0 through 13.
Yep, 0 through 13. You're starting at 0, so it's always one less. Here's an example of how you'd create an array using random values. Here's an example of how you would print arrays. Here's an example of how you would sum all the elements within an array. Here's an example where you would find the largest element within an array. Here's an instance using a for loop where you may randomly shuffle elements within indices. So say you have 7 in indice 4 and you want to move it to indice 1, you would use random shuffling. What do you notice with all of these slides though? Are these full programs? Are these going to run effectively?
No.
Nope. You would need to add a class as well as a method and put these lines of code within them. The most common loop you would use with an array, like I showed you earlier, is for the purpose of creating random values for your array, whether they're integers, doubles, strings. That's why, as I mentioned, the other options are to ask the user for input for an array, or as I showed you earlier, just create them yourself. If you want to have an integer array, you might do just 1, 2, 3, 4, 5. Or you could ask the user for input. What do you think, show of hands, is easier of the 3 options? Using a for loop to create the array elements for you, getting it from the user, or just typing them in yourself? I would tend to think the other 2 options are easier without the for loop, right? Either just getting them from the user or
Yeah, from the
creating
user.
them yourself. So slides 40 through 45 show you how you'd run a deck of cards simulation. Arrays can also be copied to store initial info in case of changes. So I mentioned banking before. What do you have available to you that you can look at each month when your balance changes? You could
You
just
get a bank
log in.
statement.
Yep, your bank statement. You can log in online to see your statement day to day, transaction. You may look at it more than once a day. But your bank statement is going to show you a month's worth of information of all the changes. So each month you have a starting balance that may want to be stored in your first indice. But then you want to, put that off to the side somewhere. Every day you should check your starting balance, right? And then it may change over that course of that day. So this way you don't get hit with an overdraft fee, right?
Yeah.
Yeah.
So here's another example. In this example, we're using a for loop to change and find out what the length of our array is. We set our integers. Now we're trying to find out the length. A little redundant because we already know the length. We have 5 elements. So we have 0 through 4. So next we have the array copy utility you can use to copy, as we showed above, one array into another. We can also do pass by value and call stacks, but those are a little beyond the scope of what I would prefer you guys to know for this course. There are also possibilities where you may need to search within an array. You can search arrays to find information you want. Why does that make the elements and index so important? Any idea?
Wait, can you say the question again?
Why, when you're searching for something within an array, make knowing the elements and the index important?
So in order for you to find the correct, like in this,
Yeah. So if you know that 5 is in your fourth index and you search for it and you print out your answer and it doesn't show 5, what do you need to do? You got to figure out what's wrong with your code because you know, let's say we have in this example, in the index 0, 5, in the index 1, 4, in the index 2, 3. If you want to get that 3, you search and you return that information. If it's not 3, you know something's up in your code that's causing an error. You did not find the correct element you're searching for. There's either linear searches or binary searches. Linear searches looks through everything. Okay, where are we finding what they're looking for? It goes through each index to find what you're looking for. But if it doesn't find what you're looking for, it's going to simply return a -1. So here in this example, we're trying to find a 3. Using linear search, it keeps going until it finds a 3. If there was no 3 in this last line, it would return out a -1. With binary search, it continues to go and just randomly pick out spots to check. So in this example, we have 1, then it skips to 4, then it skips to 9. Okay, it didn't find it in either of those. So then it tries 6, 7, 9, didn't find any of those. Then it started with 9, didn't find anything. Then it tried 8 and got it. So what do you think is smarter or better to use? Linear or binary?
Linear is longer, but I think binary is the best option.
Yeah, linear is probably better to use because it's just going to go, go, go. Say you were looking for the fourth number. Okay, it stops, it's done. Whereas binary just keeps skipping around until it finds what it's looking for. So it takes much longer to do. You can also sort arrays. Why might you want to sort an array? You probably have done this in Microsoft Word or Excel. You use that sort A to Z, put it in order. So let's say you wanted to find or wanted to print out your elements within an array from smallest to largest. You would use this example to sort arrays. It's quite often that you might more likely sort an array when you're using multi-dimensional arrays. So let's jump into multi-dimensional arrays. So in this instance, we're creating a 2-dimensional array called distances. Quite a bit of information here, right? Again, this is why getting user input or creating your own elements is probably easier than using a for loop in order to get your information or create your information to display for an array. In this example on slide 7, we're creating a two-dimensional array where each array has 10 integers. So it's going to be 10 by 10. In this instance, we're not getting any input. We're creating the integers ourselves. Again, we're using a for loop. In this instance, we're using the math.random object in order to create random numbers for us. Since they're integers, are they going to have decimal places?
No.
Nope. If we wanted decimal places, we would have to do double. So again, like in the last slide, we have some example uses of multi-dimensional arrays. In this instance, we're initializing arrays with input value. We're also initializing possibly arrays with random values, printing out an entire array, adding the elements together of an array, adding the elements based on a column, which you can only do with multi-dimensional arrays, not a single, because you only have one column. And again, just like a single array, random shuffling. So again, you would need more code to run any of these examples. You would need your class and method added in together. So who's in the mobile apps class? Lana and Zaza?
Yeah.
Yes.
So do you remember from yesterday the example I gave of the most basic example or common way that you might display a multi-dimensional array?
Was it the multiplication table?
Yep, multiplication table. So your 1 times 1 is 1, your 2 times 2 is 4, your 3 times 3 is 9, etc. Okay, so that was my basic, hopefully review to some degree of arrays. On Thursday in class, I have us scheduled to, where do I have it here? Give me 1 second. We're going to go through 4 example arrays. First, we're going to start out with displaying text, information. But since we have a few minutes left today, I'm actually going to have us do that one right now. Okay, so when you have our online compiler here, if we wanted to create
Was there more?
create an array that displays string info, we would create let's call it whatever random thing you want to call your class. Then we need to create our method. And here we're going to create an array of random words students give me. Okay? So what are we defining strings as? String.
Words or names.
So we create string. What should we name this array? Words. All right, give me some words to put in the array. Franny, give me a word.
Iceland.
Visor,
Cat.
cat, okay. So cat is our first word. Let's do 2 more words. Lana, give me a second word.
Pineapple.
Pineapple, okay. Amelia, give me a third word.
Orange.
Orange, okay. Everybody's hungry, wants to get out of class. Make sure you end your line of code with a semicolon. Next, we're going to display our student words. So we use our system.out.println. Students are hungry for make sure you close out with a semicolon. And then last but not least, we're going to create a for loop. String student, colon, words. Why do we use words? That's the name of our array. And then we print line words.
Can we just print go straight to the print statement without the for loop?
Yep. So in this example, assuming I typed everything right, I didn't. How would we just type it out without the for loop?
Would you just put words? Oh.
No, we're still getting there.
Professor, before class ends, I also have a question.
Okay, go ahead. We'll
It
focus
was
more on
about
this
the
again.
homework.
For the homework?
Yeah.
Okay,
No, the one that we just submitted.
okay,
I just
go ahead. Ask your question.
well, necessarily it's about the using the online compiler. I found that it showed my program different